Hi there. In this video, we're going to do an introduction to confidence intervals. And to do that, we're going to start with a poll. So you may be aware of Gallup.com or Poll or 538 or these groups that do research all the time. And they're constantly either have dedicated research groups or they're calling random phone numbers to find out what U.S. adults think about things. So let's take a look at this one. And I have the link for you in D2L. So it's a Gallup poll, and they're describing polling results on U.S. healthcare. Okay, so I'm going to actually go to the article and show you there, since it's in color. Headline is majority in U.S. still say government should insure healthcare. And we have some highlights right here. 57% say government should ensure health care coverage for all in the U.S. Okay, so this is the main result we're going to focus on. And often there's many polls within one of these articles. So you can see another one, 53% favor health care system based on private insurance, 43% based on government run, and then often by party, 72% of Democrats and 13% of Republicans support a government-run system. Okay, so we're going to focus on the 57% one. And what does that mean? So there's a lot of writing. I'm just going to skim through this a little bit. You're welcome to read more on your own. And then here's the graph that I have printed on the notes. And I wanted to show you this because you can see this goes all the way back to 2000. And I'm sure they were collecting it before then as well. And this is one of those polls that they repeat periodically. So you can see where these little endpoints are. These are where they've done a poll. There's nothing in between. So they're just kind of connecting the dots with a line. So this is 2000. Is that 2000 or is that 2000 adults? Oh, here we go. 2001. So it looks like maybe they're doing it twice a year. It might vary too. There's 2002, there's a 2003, 2004, 2005. Okay, so they're doing this roughly once a year, except for maybe twice in a couple years. And I'm on the green line right now that says yes. People who responded, it is the government's responsibility to ensure health care. And then the other one is the red line where people say no. And you notice they may not always add up to 100, right? Because some people may be undecided. Okay, I don't know if that's non-response bias. I'm not sure. I'd have to dig more into that. Okay, so we want to understand more about this 57%, right? That's the last value, but you can see it's been going up and down. And there was a period where this green line was under the red line, but a couple periods. But more often than not, the green has been higher. And also, is that just due to sampling variation? Or is that statistically significant? So that's another thing we want to look at. Okay, so I'm going to scroll down. Usually when you're reading one of these articles, you want to go down to the very bottom and look for the methodology. Okay, so I'm going to scroll kind of slowly so it doesn't make anybody seasick, but you can also just look away for a second if you want. I'm looking for, okay, here we go. So down at the bottom, there's a box here and it says survey methods. So I'm going to click on that. This is what we really want to focus on. Okay, so it says results for this Gallup poll are based on telephone interviews conducted November 9th to December 2nd, 2022, with a random sample of 1,020 adults aged 18 and older, living in all 50 U.S. states and the District of Columbia. For results based on total sample of national adults, the margin of sampling error is plus or minus 4 percentage points. Okay, so that's, for example, the one we're looking at, the 57%, is from their whole sample. When they separate just Democrats and Republicans, that's now a part of a sample with less sample size. So that wouldn't be the plus or minus 4%. At the 95% confidence level, all reported margins of sampling error include Computed design effects for weighting. Okay, so we're not going to get into weighting. Each sample of national adults includes a minimum quota of 75% cell phone respondents and 95% landline respondents, with additional minimum quotas by time zone within region. Landline and cellular telephone numbers are selected using random digit dial methods. In addition to sampling error, question wording and practical difficulties in conducting surveys can introduce error or bias into the findings of public opinion polls. Okay, we have studied that, right? We've studied the different types of error or bias. Question wording could be one of them. It would be response bias. Anything that affects someone's response would be response bias. Okay, often with quotas too, what they're trying to do is match the demographics of the U.S. population. So they might have certain quotas, they call it by race, ethnicity, gender, age, different things like that. And then so they're trying to fill in and make a little mini representative sample with this 1,020 adults. They didn't describe, sometimes I've seen different studies describe that in more detail. They didn't describe that here. Okay, so I'm going to shift back to the notes for a second to look at what information we're looking for from this study. Okay, so I've got the graph here for you for reference. Okay, so what we want to know, these are the things we're going to be working with, and I'll define them. Of course, this is just by way of introduction, so you can get a sense for what this has to do with real life. Sample proportion or point estimate, and that's our p-hat, and we've worked with p-hats before. That is our 57%, or I'm going to, because it's written as a proportion, I'm going to write it as 0.57. Okay, and so this is our p-hat right there, our latest one. Okay, margin of error, sample size, and confidence level. Okay, we saw all of those things there. Sample size was 1,020, right? Let me just double check. 1,020 random sample. Okay, so I'm going to write 1,020. Margin of error, that's the plus or minus. So they're saying it's plus or minus 4%. And confidence level, 95% confidence level. Okay, so we have all the information we need. 95% confidence level. Okay, so now let's talk about what all these things, well, not quite so much detail yet, but I'm going to show you how we're going to calculate confidence intervals. Then I'll explain everything in detail in the next video. So what a confidence interval is it gives a plausible range for values of the parameter that we're trying to estimate. So here we're doing a proportion, but we could also do a mean or difference of proportions or difference of means. This range is used to account for sample-to-sample variation. So we've seen standard error already, and we have an idea about sample-to-sample variation. So this is only 1,020 adults, right, in this data point. And so is it really up from last time, or is that just sample-to-sample variation, right? So what might be interesting is if we had like a little confidence interval around each of these points, and you might see a graph like that where each can't tell exactly where, but where each point has this range around it, because often in the media they report a single value, and that's called our point estimate. They report this single value. People think, well, that's what it is, 57%. But is that really what it is? We know there's sample-to-sample variation. So the 57% is an estimate, right? And they bury that plus or minus 4% all the way down in the methodology. I'd have to look again to see if they put it in the article anywhere. I'm not trying to hide it. I don't know. It's just how the media does it, I guess. But it's not quite how statisticians do it. So we want to give a range, and that is the plausible range for the population parameter that we're trying to estimate. So to calculate our confidence interval, what we're going to do is take our 0.57 and we're going to add, actually, I'm going to need to change this into 0.04, right? So they're both in decimal form, or they could both be in percentage form. but we need to have them in the same format. I'm going to subtract the 0.04 and add it to get that range on either side, okay? And I'll just write it out over here. So I'm going to do 0.57 minus 0.04 and 0.57 plus 0.04. So let me move this up and get my calculator out. Oops, sorry, I got something in the way here. There we go. Okay. 0.57 minus 0.04 is 0.53, and you could probably do these in your head as well. You're welcome to. 0.57 plus 0.04 is 0.61. So what that's saying is our plausible range at this 95% confidence level, which I'll explain what that means, the plausible range for the true proportion is 0.53 to 0.61. Or we could write it in percentages as well, or 53%. Oh, sorry, we write a comma. We put it as an interval, like you may have seen in algebra or calculus, 53% to 61%. And I'll get rid of that extra little dot. Okay, so that is our confidence interval right here. It's written as with the parentheses with the smallest to largest. So let me write that. Always put them in numerical order. Okay, and so here's the interpretation of what this means. It says, it's kind of like a fill in the blank interpretation. It's a little bit formulaic. To interpret the confidence interval, we are blank percent confident, so we're 95% confident that the true proportion of blank, so this is what we're trying to estimate, this is our parameter, is between blank and blank percent. Okay, so we're going to fill in, it's like insert context here. We're inserting our parameter that we're trying to estimate. So I'm going to say, I'm looking back up at the title. Majority say in U.S. say healthcare is federal government's responsibility. True proportion of, and this was U.S. adults who think healthcare, or I could say either one, is government, and I'm going to abbreviate just a little bit, government responsibility. Is between blank and blank percent, so 53% and 61%. So we're 95% confident that the true proportion of U.S. adults who think healthcare is the government's responsibility is between 53 and 61%. Okay, so it doesn't mean we know that it's between there, but we're pretty confident, okay? Okay, so I hope this gives you a good introduction to confidence intervals, and we'll get more specific into what all this means in the next video. Okay, I'll see you there.